Hello, and in this program I would like to show you how you can write a program to measure an event. For example, an event might be the time it takes a car to go from location A to location B. So at the two locations called A and B, you would have a sensor, and the sensor goes to the computer, and the computer, you could use port B, for example, or C or D. In this program I am going to use port B. And I'm going to measure the time between two pulses going into port B. So, in the main program, let's write sort of like a flow chart. I'm going to do something like this. I'm going to wait for the first pulse to come in, and the code I'm going to use is this. Wait for high on PB0. Now that's a subroutine I've already written. Then, when the high comes in, the first pulse comes in, we turn on the timer and we set to 0. We then wait for a low on PB0. That's also another subroutine that I've written. And then we will wait for a high on PB0. And after that, we are going to read the timer. And that'll do it. So you wait for a high, turn on the timer, you wait for a low, you wait for a high, and then you read the timer. So we are measuring the time between the first high and the second high. And again, what we are referring to here are pulses. 2 pulses. Now the subroutines to do this wait for high and wait for low are shown down below. And they read as follows. They're basically a while loop. And in the while loop, we get the pin value from port B. We isolate the bit that we are looking at, which is PB0. So I'm using a 0B01 bit mask. And that will mask out all the other bits. We compare it to, in this case, a low, because we're looking for a high. And when we're looking for a low, we compare it to a 1. So when we get the 1, we're not low, so we keep looping. Well, okay, now I need to go back to the main program and replace my comment with actual code. So to turn on the timer, we do this. And the rate will be 1 microsecond per count. Then we have to set the timer to 0. And these two registers, these two lines accomplish that. And if you want to know more or where I got that from, you can refer to the book. Then we come down here, we have to read the timer. And to read the timer, the actual code is this. Unsigned int t, or, t for time is good, equals tcnt1. And that value then will go into t, and t will be an integer, and furthermore it should be unsigned because you don't want negatives. And this is to read the time. Well, that should do it. I did compile it. It does compile. I took out some comments, and yeah, the code looks pretty good. It's pretty simple. As shown here, you basically, again, turn on the timer, set the time to 0, you wait for something to pass, and time-wise that is, and then you read the timer. And here, by the way, you can read the time into t, and t will be the number of microseconds that it took. So let's put that in as a comment. T is equal to the time passed in microseconds. If you would like the time to be, say, in milliseconds or at a different rate to get a longer time, then you would come back up here to the TCCR1B and change this to a different number, a number that is then counts slower. This is the fastest rate. And now mind you, the biggest value that t can be is 65,535. And so if this is in microseconds, this would be the biggest time period that we can measure, which is only 65 milliseconds. So if your event takes longer than 65 milliseconds, then you have to come up here and put in a slower rate for counting.